Let's see our last sorting algorithm. The same thing. We will do the QuickSort. The QuickSort also have the n log n runtime. So we see the idea how we do the QuickSort. The QuickSort actually is every iteration after we finish, we will have a pivot. So this pivot actually, when you start, you can decide which index you want to do. So most of the time, people using the middle index or the first index in the 0 using the pivot. But after iteration, if after one iteration, the pivot will divide your array into two parts. The pivot will kind of be in the middle. So then you have the sub-array, sublist is 1 and 2. The sublist on the left-hand side, all the value, they are less than the pivot. On the right-hand side, the list 2, all the value will be greater than pivot. So actually, every iteration after you finish, you have the pivot in the right location. So then both sublists, they kind of in the right location, but not so well. They only is list 1 is less than pivot. All the value in the list 2 is less than the greater than pivot. So after you have one iteration done, right? So then right. So since we know, then we only do the list 1 and list 2. Again, list 1, you will do the quick sort again. You will find a pivot. So then afterward, your pivot will have it kind of in the middle. So then you will break into the two lists. So this one actually is, you will have the recursion function to do one by one. Because each time you only have your pivot at the right location. So then recursively, you will apply the algorithm into the first list and the second list. So once your pivot, or we see the list, they are size only 1. So then we finish the recursive code. So your algorithm look like here. When you start your quick sort, you can pass your list. So you can see here, you can pass the list by pointer. So on the other hand, this quick sort algorithm, they work either on array or linked list. So as long as your list size greater than 1, I continue. Otherwise, we finish. So if your list size greater than 1, so then choose a pivot. So you use the index, or for the linked list, you can just using the first node as a pivot. So then you traverse your list. So after you partition the list, actually the partition means you traverse the list for each node one by one. So then afterward, you will make all the lists on the left-hand side, the list 1 will be less than or equal to pivot. And all the elements in the list 2, they will be greater than pivot. So then you see you call the recursion function again. So you will have your quick sort. So once each quick sort function finish, so then you're sorting done. So it looks like very simple in your quick sort, right? But one thing you can see here, actually, we only have the recursive code, but the most important thing is we're missing one more function. So this function is, how should we do the partition? So after you have your quick sort code, right? So actually the most important thing, after you choose the pivot, you need to code the partition. After the partition, then we will break that into the two lists. So that the list will be in the order. So that's focus on the partition. So whenever you have your partition, you need to give me the list pointer. So then we have the start and the end. So that's why you see here, you know your start node and end node, right? So usually, like we say, your pivot, you can choose any element. But in order to work with the array, both array and linked list, usually we make our pivot is the first element. So then you can set your low and high index. They look like this, okay? So you have the pivot is the first value, on the first value index equal to 0, or the first pointer. So then the next one, we will have a low pointer to refer to that. Then we have a high pointer pointing to the last node. So this pointer will do what? They will keep moving. Okay, so when the low point to the value, this value is less than the pivot, I increment. So you see, I just move until you see 9 is greater than 5. So I stop. Okay, so once your low index point to the value greater than the pivot, you stop. The same thing, then you do the high. High, the same thing, high will continue to decrement. As long as the value point by the high is greater than pivot, I decrement. So 6 greater than 5, I decrement. So become 1. So 1 is less than 5. So once the height meets, the value is less than the pivot, I stop. So once my low and the high, they both stop, right? And they are not out of the boundary. So then after they stop, actually we just swap the value between low and high. So you see here, 1, okay, oh sorry, it's 9. 9 is greater than 5, right? So we stop for the low. So then high is 1, less than the 5. So then we swap 9 and 1. So after the 9 and 1 value being swapped, right? So then we can continue to move. So that's why low can move 3 until 8. So then high is 9, continue to move until 0. So 0 and 8, again we swap. So then the low can move, right, until 4, actually continue to 8. So then high, you will continue see 8 greater than 5, continue, I move to 4. So when each iteration will finish, until your low and the high, actually they cross each other. Yeah, so supposedly our condition is when the high always greater or equal to low, right? But once your high is less than the low, actually we know we finished this iteration. So after we finish this iteration, you will see then we will swap the pivot with the high. Then you see 4 is here, 5 is here. So that's why after the partition, you see here, our pivot is in the middle, kind of in the middle. So then you have 2 lists. So that's why your 2 lists, you can continue to code the QuickSort with the sub list. So then they can continue to do that. So that's the partition. So you will see the partition, actually the algorithm is we will set our pivot for the first element. So you have your low and high index. So the condition is when the high greater than low, I just keep moving the pivot. I just keep moving the high. So when the high is still greater than the low, right? So you see swap the high and the low value. So once you finish, when they cross, right? So then we just have our pivot value to be considered the pivot value and the high value index. Should we try to swap that? So that's why at the end, after you finish, you just need to return your pivot location, because after you return the pivot location, we know the list 1 and list 2. So this QuickSort algorithm, they are working on either array or the linked list. So that's why this example actually is for the array implementation. So you're passing the array pointer, so you give it the size. So here, actually, we're just using another QuickSort overloaded function. It's just easier for us to give them the star index and n index. So then this one is, earlier we say the size greater than 1, right? So that's why as long as the n greater than star, that means the size is greater than 1. So then you will call your partition function. So once you got your pivot index, so that's why you can call the QuickSort again to give them the 2 list. And then we give you the example for the partition. So again, the partition here is working on the array implementation. And also you have the driver program, you can test your quicksort.cpp file. So that's in our canvas. So you should try to run and see each function how we implement. So different from the merge sort or heap sort, heap sort and merge sort, they only work on the array implementation. But the QuickSort, you also have the linked list implementation. But your linked list, you need to do the double linked list. Because you can see here, because we need to go forward, we need to go backwards. So that's why your node struct, you have the next and the priv. So after you have your linked list, of course, you pass in your start node and your end node. So that's why not only they have the doubly linked list, and also the list, they need to have the first pointer and last pointer, or here we call the start and the end. So so that the QuickSort still is a recursion function, right? So the recursion condition actually is here. As long as your start not equal to the end. So you see you have your pivot, you have your partition. So then you will break that into two lists. So this one, the same concept work on the linked list. So that's why you will see here your partition, how they work. You will see still they are the same algorithm. But one thing is when you do the linked list, you pass in the start node and your end node. So then your low and the high pointer, be careful, your pointer still is the node pointer. So that's the, let me see. Okay, so that's here. You see that's the QuickSort for your linked list version. So then when you give me the start and the end, so then we will have our base case for the stop the recursion function. So then the same thing, you need to have your partition function to return the pivot pointer. So then your QuickSort, you go to the to list. So that's the linked list example. So the same algorithm, just different syntax. So again, the same thing. We do have the QuickSort in the linked list example. So I put that in the canvas so you can download to try your program. Okay, so why the QuickSort, they still runtime is n log n. Okay, so actually the n came from the partition. So each partition, you see, they go over every element. However, whenever each iteration, we break the list into two lists. So that's why the step, the same thing. Ideally, if the pivot is good, so then you will have log n iteration. But like we say, remember big O always is average case. Sometimes they may be more, they may be less. But one thing is, because the QuickSort, we try to do the same thing. Every iteration, we break that into two groups. So that's why here you will have the two, we kind of got the average for the log n. So that's why the QuickSort runtime also is n log n.